Hello everyone, welcome. In this tutorial we'll be exploring sheet metal modeling in detail. We'll cover the extrude features and different types of flanges at various angles, how to apply corner breaks and add a cutout, and finally we'll be working with the sheet metal table and a flat view. Let's get started. So you're really in a part studio environment. Now we're going to create a sheet metal base. So let's select the front plane as the sketching plane. Now draw a base profile, for example, a line or a rectangle, and apply the necessary dimension to define its size. Once the sketch is complete, confirm it with a green check mark. First, open the sheet metal workspace. Now from the toolbar, activate the Extrude tool inside the sheet metal tab. The sheet metal extrude dialog box appears. Here you'll notice it works differently compared to standard extrude. Instead of creating a solid, it generates a sheet metal base with uniform thickness according to the default sheet metal rule. Inside the dialog box, you can customize several options. First, you can customize the end type. Use the drop down menu to choose how the extrusion should terminate depending on your design requirements. You can also specify the desired extrusion depth in the depth field. Alright, now let's understand the symmetry. If you want the extrusion to grow equally in both the direction, enable the symmetry checkbox. You can also specify its thickness value in the value field. You can also apply bend radius to control how sharp or smooth the bends will be during forming. If you want, you can flip the directions if needed. Additionally, the material settings allows you to define how the sheet behaves during bending. You can specify K factors, bend allowance, and bend deductions. These parameters assures accurate flat pattern development for manufacturing. Finally, in the relief section, you can set the relief depth and relief bend value. These helps to prevent tearing or distortion at bend intersections. Once all parameters are defined, click the green check mark to confirm. Your sheet metal base is now fully created and ready for next steps in modeling. Now let's add flanges. Activate the flange tool from the toolbar. Now select the edges of the base and you'll see a preview of flange appears. You can set the distance, also control the angle as per the design requirements. If you want, you can also flip the direction of the bend. Okay, there are different types of flange alignments you can use. It helps to align the inner wall of the flange walls with the inner edge of the side lip. Then the outer aligns the outer wall of the flange wall with the outer edge of the side lip. Okay, so middle, which aligns the middle plane of the flange wall with a theoretical line halfway between the inner and the outer edge of the lip. Finally, hold the line aligned, the bend of the flange at selected edge or a face. Now choose the appropriate type. Here you can see with the image, which also tells the difference between them. It will be more understanding. Automatic metal. If checked, automatically trim or extend the intersecting flanges or a meter. Uncheck to specify the custom meter angle. You need to enter a custom meter angle value. Use the model bend radius. If it checked, to use the inside bend radius specified for sheet metal or leave unchecked to enter a custom bend radius. Once you're done, confirm it with the green check mark. If you want to repeat the process on the other edge, you can do it. This way we can create flanges at different angles to form the sheet metal walls. So let's create another flange within different angles and length. Again, activate the flange tool. The dialog box appears. Now specify all the parameters. Once you're done, click the green check mark to confirm it. Here you can see the preview that the flange tool gives a complete overbuilding sheet metal walls by adjusting height, angle, alignment, bend radius, and metering options. By experimenting with different flanges types, and parameters, we can create precise wall geometries that suits any design requirement. With this, you now understand how to add and customize flanges to extend your sheet metal model effectively. Okay, so in the sheet metal design, sharp edges can cause issues during manufacturing and may even lead to cracks or unsafe handling. To overcome this, we use the corner break tool, which helps to smooth out the sharp edges by applying either fillet or chamfers. Let's smooth the sharp edges by applying a corner break. Activate the corner break tool. The dialog box appears. Here you can see it has two tabs, fillet and chamfer. So in the select measurement type, either radius, which specifies the radial measurement of the fillet, and the width, which specifies the distance between the two ends of the fillet, and a constant width. Okay, now let's see a control type, distance, in which fillet has a circular edge with a radius and value entered. Onshape remembers this value when creating the new fillet. Then the other is conic, which helps the fillet has a conical edge with the radius value you enter and optionally a row value to define the style of the fillet. And finally, the curvature, which helps the fillet to match the curvature of the surrounding edges with the radius value. Enter and optionally a magnitude value between 0 to 0.999, which is the tendency. Now choose the appropriate type. You can define the fillet radius and select the edges you want. These steps help us in avoiding sharp edges and makes the sheet suitable for manufacturing. By applying corner breaks, you not only improve the appearance and the safety of the sheet metal parts, but also make them easier to manufacture without defects. It's a small step that adds a big value to overall design quality. Okay, similarly, the options have fillet has, chamfer also had the same options. Okay, now let's see the sheet metal design, which we need the opening slots for the functionality, such as ventilation holes, mounting points, or a space for fasteners. To achieve this, we use the cutout feature, which removes the material from the selected area of the sheet metal. Begin by starting a new sketch on a desired face of the sheet metal part. Draw a required profile, such as rectangle, for a slot. Once the sketch is complete, activate the Cut Extrude option inside the sheet metal workspace. The material inside the sheet metal profile is removed and the cutout is applied to the part. This gives us a slot in the sheet metal where needed. So the cutout tool is simple yet powerful. It allows you to introduce a functional features like holes, slots, and vents, making the sheet metal part ready for assembly or real world use. Finally, let's understand working with sheet metal table and flat view. With an existing sheet metal model, open in Part Studio. Let's explore the sheet metal table and flat view. Click the sheet metal table and flat view icon located midway along the right side of the window. Now you can interact directly with both the table and the flat view. Click on the rows in the table to select them and click again to deselect. Notice the cross highlighting when you select something in the table, it also highlights in the flat view and in the 3D model and vice versa. For bend segments, you can edit values directly in the table. Double clicking on the cell to enter a custom K factor, bend allowance, or bend deduction. If you typed an invalid value, the cell will turn red and display a tooltip with a valid range. Similarly, you can double click a radius value to enter a new one. As you make changes, the flat pattern and the 3D model updates instantly. The sheet metal table and flat view gives you a powerful control over your design by directly editing values like key factors, bend allowance, bend deductions, and radii. You can even fine tune accuracy of both the 3D model and the flat pattern with the real time updates. And cross highlighting, it becomes much easier to manage and validate your sheet metal parts before sending them for a manufacturing. Once reviewed, you can exit the sheet metal environment and return to 3D model. Go to the sheet metal drop down list and select exit the sheet metal. The dialog box appears. Now select the part for the graphic area or from the part list. Once you're done, confirm it with the green check mark. And that's it. We learned how to use sheet metal, extruding feature, create flanges with different angles, apply corner breaks, add cutouts, and finally unfold the sheet metal. These tools make sheet metal design efficient and ready for real world fabrications. If you found this tutorial helpful, don't forget to like, share, and subscribe for more CAD modeling lessons. Thank you.